All right, ladies and gentlemen, let's talk about calculating total resistance in parallel and just review this. So in resistor 1, yellow is equal to 4, violet is equal to 7, and then red is equal to times 100. Okay, so this resistor 1 is equal to 4700 or 4.7K, right? Resistor 2, green is equal to 5, black is equal to 0, that makes 50. Again, it's times 100, so we're going to add 2 more zeros on. That's going to be equal to 5K. The circuit is parallel. There are multiple paths for the electrons to follow as they come around. And again, they're going to split themselves up in a very specific and mathematic kind of way. So we can determine what the total resistance of this is with the formula 1 over resistance total is equal to 1 over R1 plus 1 over R2. So when we look at this, don't forget the first part of this equation as you're moving forward because you're going to need that later on. We have 1 over 4,700. Don't use metric prefixes when calculating. Plus, sorry about my chicken scratch here, 1 over 5,000. Okay, so when you go to calculate that, we're going to be coming up with 1 over resistance total is equal to 0 point, and it's a super small number, 0.00412, and it continues on from there. Okay, so again, if you take this number here, and if you raise that to the -1, that's going to basically solve for this side of the equation here. So when you take that number and you go to the -1, resistance total is equal to 2,422 ohms. Running out of space here, so I'm going to erase a little bit on the top. So 2,422 ohms. If we take our decimal place and go 1, oops, wrong pen. And if we go 1, 2, 3 over, that gives us 2.422 kilo ohms. Round that to the nearest tenth. So 2 points, because after the 4 it's a 2, which is less than 5. We're going to stick with what came before. So 2.4 kilo ohms. Okay, so in total, as electrons come out of here and come out of here and then return back again, they're going to see a total of 2.4 thousand ohms of resistance to the circuit.